In 35th question, we have a twice differentiable function which satisfies the property that f double prime plus minus f prime minus f minus 1 is equals to 0 for all values of x. Furthermore, it's given to me that f of 0 equals to 0 and f of k is also equal to 0. So basically, on the real axis there are some points 0 and k over which this function takes value 0, right? Now I am asked about the functional values between 0 and k. So let there exist x belonging to 0 to k such that f of x is positive. So there exists some x. Let's call this as x1. So there exists some x1 such that f of x1 is positive. So if the function sometimes goes up, it has to come down as well. So so this implies that there exists x2 belonging to 0 to k such that f of x2 is positive and f prime of x2 is 0 and f double prime of x2 is negative. Basically, if it reaches this point, positive point, then there should be a point like this. That's what I'm saying. So what I'm saying is there should be a point like this, x2, where the function is positive and its partial derivative is 0 and its double derivative is negative. So there should be a local maxima of this function above the x-axis. So there exists a local maxima above the x-axis. That is all I'm saying. Okay, because the function is twice differentiable, so it has to be continuous, so there is no other way to go about it. Then for x2, if I check for f double prime is negative, all right, f double prime is negative, f prime is 0, f is positive and minus 1, so this entire thing has to be negative. So this violates this property. So that's why we have a contradiction. Right, so we have a contradiction, and so we have a contradiction, and that's why we can say that this function can never take positive values. Now let's look at negative values. So if f takes negative values, then the function would look something like here. Let's say it takes a negative value. So all I can say for sure is that if the function takes all negative values, then there is a point like this x2. Okay, if f is always negative in 0 to k, then there exists a point x2 such that f of x2 is negative, f prime of x2 is equals to 0 and f double prime of x2 is positive. So if I apply these properties to f double prime minus f prime minus f minus 1, okay, so I know from this result that f double prime is positive. This thing f prime is 0, f is negative, and you have a minus 1. So it is possible to get 0 provided my f double prime minus f is equals to 1. So if this result holds at x2, then it is possible. So it is possible to get negative values, but 0 is not possible. Also, you cannot have this function as a constant 0 everywhere. So that's my case 3. So if f is constant 0 in 0 to k, then for all x 3 belonging to 0 to k, you would have f equals to 0, f prime equals to 0, f double prime also 0, right? So this would imply that f prime double prime minus f prime minus f minus 1 will be equal to minus 1. So that's a contradiction. So the final result is that hence f is less than 0 for all x belonging to 0 to k. So it cannot be constant also. Okay, so it cannot be constant in any range a to b. In any subsegment a to b, which is a subset of, let's say, if f is constant in x3 belonging to a to b, which is a subset of 0 to k, then for any x3 in this range this would hold, which is a contradiction. So it cannot be even a constant 0 in any subsegment. So it cannot even look like this. All right, so even this is not possible. Okay, so this is also not possible.